Yeah. So in this class, let's go full deep into IP address mostly. So as I told you before, MAC address and IP address are used typically to send the data. Let's say I'll just MAC plus IP usually used to send or receive the data. Receive the data. So since we know the MAC address, let's try to understand IP address. So we were telling that MAC address is unique and permanent, but IP address not. So just a thing, there is a question. Okay, okay, okay. So let's say IP address is temporary. It's not permanent. It's a temporary address. It's used when you want to connect to a network. So IP address is only used when you want to connect to a network. So what's a network? So network, we already know. A network is nothing but a bunch of computers or a bunch of devices. Bunch of devices you can call network. Even you can say that your headphones and your mobile phone, that's a network because your headphones are connected to your mobile or laptop. That's also you can call a network. So typically network means a bunch of devices. It could be two devices together, 3, 4, 10, 20, 1,000, million, all we call network only. So IP address is only required when you want to connect to a network. So that's the main idea. If you don't want to connect to a network, you don't need IP address. You can use MAC address to send the or receive the data. But when you feel like you want to connect to a small network or long network, anything, you require IP address. And it's temporary. It's not permanent. In the sense, let's say a computer came. It is assigned an IP address. Let's say something like IP address 1. I mean, just for let's call. Then the computer goes away. Another computer comes. So it is possible that the same IP can be assigned to this also, but only one IP at a time. No two IPs can have same. You can see this same IP you can use for another computer also. It's not like a unique thing, but not at the same time, different time. Right? So typically in the real life, at your home, IP address is allocated by your router. Example, let's see when you are connecting to Wi-Fi. Let's say when you connect to Wi-Fi by entering username and password, the Wi-Fi device, the Wi-Fi router, will give you one IP. The Wi-Fi router will give you one IP. So similarly, you can connect to many phones or laptops to Wi-Fi. Each time you connect, the Wi-Fi router will assign you an IP address. That's unique to you within the network. So that's the high level idea. So mostly recap points you need to know IP address is like, hey, IP address is used when you want to connect to a network. And it's temporary. One IP at a time. You cannot have two computers or two devices using same IP address. It's allocated by your Wi-Fi router, let's say, for your home use cases. But for company use cases, you have a different way. But let's see homes, let's at least. So now let's see what IP address looks like. Let's see. Typically, there are two variations. One is we call IPv4 version 4, which is a 32-bit address, something like this. Example, sorry, something, whatever. All are 32 bits. Or you could if you convert them into decimal format, it would look like this, maybe 10.34.22.1. So these are the decimal values. 10 means, let me just take some help from ChatGPT to convert decimal to binary. Yeah, something like this. Again, if you don't know what decimal values, binary values, it's okay. I would recommend you to maybe try it. But at this time, even if you don't know decimal binary, it's okay. Just hear me out. So 10 means this is the binary value, 34 means this is, 22 means this, 1 means this. So in a way, this IP address is formed by like this, something like that. Yeah, that's, yeah, you can see this is a decimal IP, same IP, decimal, this is binary. So this is one example, just random IP address. So these are 8 bits, 8 bits, 8 bits, 8 bits. That's how you get 32 bits. 8 bits, 8 bits, 8 bits, 8 bits. So that's why you have 32, total 32 bits, like that, 8 times 4. So any number you can give, but let's see one thing. Let's tell you some range, IP range. So the IP range starts from 0.0.0.0. Similarly, like this, you have multiple IPs, 0.0.0.1, correct? 0.0.0.2, 0.0.0.0.3, and so on. You have up to 0.0.0.0.255. You can only have 255 max number because I'll tell you, 0 means binary, all zeros. 255 means all ones. 3, 4, 10. 10. All zeros, all ones. So that's why you can only have up to 255 bits. Then again, one starts 0.0.1.0. And again, they continue 0.0.1.1, 0.0.1.2, and so on, all the way 0.0.255.255. Okay. Then again, it starts 0.1.0.0, 0.1 dot again, you can, all combinations you can try, all the way you go, it looks like 255.255.255.2. That's the max range. So anyway, you start from 0.0.0.0.2 all the way to 255, 255, 255, 255. If you count each of them, like 1, 2, 3, 4, 5, so the total values would be total IPs, but around 4 billion. 4 billion IP addresses are there between 0.0.0.0.2 to 255. So that's all possible. You can only have 4 billion unique IPs in the entire world. Yeah, just little better way. Yeah, same only. Total size is 32 bits. Around 4.29 billion, like, to be precise. So you can have 4.29 unique billion addresses, like IP addresses available. They increase like this, 0, 0 all the way to here, then here, and so on, all the way last. Something like This is just again hexadecimal format only I'm telling you, not like too much. But if it's too difficult, it's okay. Even if you don't know, that's fine. But you can think like there are 4 billion unique IP address available. Just that point is good enough for you. But it's better if you understand the pattern, right? You can see, for example, let's say if I check my IP address, my computer, let's say I'm connected to this Wi-Fi, my Wi-Fi. So I'm going to my settings. You can also check your IP address by typing, I think Windows is ipconfig. Uh, for Windows, you can enter it. You will get all the addresses, or you can try ipconfig all. You will get all the addresses for Windows, guys. Since I have the Mac, I will use ifconfig. All doesn't exist. So yeah. So I can see my IP. So many addresses are there, but you can ignore it. Let me see it. Hmm. It's not there somewhere. Okay. This one. This one. That is my IP. Or I can manually go check on my Wi-Fi. Details. No, this one. This is my IP address. So this is a router IP address. You can see this is my IP. I'll just write it down. And this is a router IP. I'm pretty sure if you're at home connected to your own Wi-Fi, I'm pretty sure you will get like this. At least these two are fixed. This also probably like one only. I mean, you have to check. You only tell me. But this can change. Sometimes this can be 30, a bit 20, 10, 29, whatever. This can change. This number can change. But this number also, this number, let's say I'll put X. This number can change. But I'm sure if you check on your Wi-Fi at home, I'm sure you will have this exact IP for your router. For your computer, it's the same. This X also something different, depends on the computer. Maybe one computer you have one, sorry, two, phone you have three, maybe in any other computer you have four, and so on. So this number can increase. This number also probably fixed for you, but I'm not sure it's one or two or three. It would be same, it would be different, depends on your ISP. Mostly these we call local IPs, but I'll tell you what IP different types. But just want to tell you, this is my IP. If anybody can ping in my network, let's say if I ping myself, I say ping, enter my IP, you can see IP is active. Ping means you're basically asking is it active or not. It will respond something like some reply is there. So it's working. If I bring one also working. So these two are active. Let's try two. Two is not active because two, there is no two. Let's try three. Three is active. Okay, got it. Three is active, but you got requests. But anyway, three. Somebody in our room, somebody might be using three, or maybe my mobile only. It's blocking the request also, but it's okay. Four, four is a no, and you can say all the way to you can try 255, but 255 always give S. So I'll tell you why, but you can try up to 254. I'm pretty sure your computer also will have pretty much same address. Only this they're different. This is different. Depends on your internet provider. Yes, just want to pause and see any questions, anything so far. You can text me any questions, anything so far, IP address. So let me ask you a question if you don't have. Can a one computer, let's say can a computer have two IP addresses? Yeah. Can a computer have two IPs? Yes, no, maybe. Yes. Sorry? No. Okay. 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 No. Technically, yes. So this is where there is a concept of public IP and private IP comes. So there are two types of IPs in a way, public and private IP. So right now, this IP address, this is not a public IP. This is a private IP. This is my computer private IP. So every computer or every device have two IPs at home, at least at home our side. My computer also have public IP also. So I will show you my public IP. You can search public IP. Public IP is my IP address. If you Google it, you can go check it out. What's my IP address? You can see this is my IP address. And I'm currently at somewhere in Hyderabad. So you can see exact point also, right? So it's a halfway cable. It's a ISP internet service provider, Hyderabad, India. So this is my public IP. So in a way, yes, computer can have two IP addresses, but one IP is public, another IP is private. So I'll tell you the difference, why public, private. But you can say that, yeah, a computer can have two IP addresses. One is public, another is private. But you cannot have two private IPs. That you can't. You can't have two private IPs. Similarly, you can't have two public IPs. But you can have one public, one private. I'll tell you the difference, what is public and private. So I'll tell you. So the reason why we have public and private is, if you recall it, we only have 4 billion unique IP addresses possible. Only 4 billion. But number of devices on Earth, not 4 billion. There are many billion. You have billions of devices. So if every device, if you give a one unique IP, then we will run out of these IPs. Because that's the reason. Let's say if you look at basic check, how many devices exist on Earth? Roughly. Let's say roughly. You can see over 30 to 35 billion devices connected. So since we have only 4 billion, if 30 devices wants to connect, we cannot give each thing because we'll run out. Like you can see smartphones only 7.5 billion. Laptops another 2 billion. IoT device another 25 billion. That's it. So anyway, 35 billion devices are connected. You cannot give each IP to each, even phone, to 7.5 billion. So that is why what they do is, hey, let's use one thing. Let's create one public IP for a network. Let's say our home. That those devices who are connected, sorry, who are connected can have private IPs. For example, at our home, I have one Wi-Fi. So the Wi-Fi has one public IP. So that is this. But at my home, I have 5 devices, maybe 3 computers, 2 mobile phones. All these 5 devices, let's say, maybe I'll go open I think it's better if I tell you in Cisco packet tracer. Let's do that. Okay. So let's say I have a computer, I have home. I have maybe 3, 4 computers, example. I'll take some text. I'll take some router or something. This is my router. This is a Wi-Fi router, not the industry router. Let's assume that it's a Wi-Fi router. I'll just connect it. Wi-Fi router. Think like this is a Wi-Fi router, not internet router, because routers cannot connect directly on that. You have to switch. But just assume that this is a Wi-Fi router. So I'll just add a text maybe. Wi-Fi router example. Or you can take it. So let's say this is IP address. I'll just give bigger 192.168.1.2. 192.168.1.3. 192.168.1.4. 92.168.1.5. Simple, right? And this is finally 192.168.1.1. Yeah. Yeah, that's it. I hope you can see the screen. Yeah, maybe you can see this better. Just observe it. The router has IP address 192.168.1.1. This is 1.2. This is 1.3. This is 1.4. And this is 1.5. So all these devices got the private IPs. These all. Now all of these connected to this router. The router will have a public IP, something like outside. So that public IP we can call, let's say, it's roughly. Sorry. Okay, it's not happening. Just a second. Why is that? That's what's happening. Let's see. 115. Oh, okay. Sorry. Let's say something else. Now you can see this is the public IP. This IP address is allocated to the router, and each device connected to the router have private IPs. So let's say this computer wants to google.com. So he types google.com in the browser. So this message, the google.com message, will go to the router. The router will send this message to external. External means internet. Let's say outside internet, somewhere, like outside. Now, when it goes to outside, this IP address is hidden. This will come. So Google perspective, Google will show only this IP address. Hey, somebody is requesting my page. That is this IP, not this IP. Not this IP. Google will only know this IP because this is a public IP. So in a way, for one 5 devices are there, we can only use one public IP. That's enough. So this is why you can have 4 billion device unique IPs can be manageable. You can have 100 computers here, but still one IP, one public IP. In that way, we can utilize the all 4 billion. You can have 200 computers here. You can only have one IP. So every time you make a request, either this computer, this computer, this computer, this computer, google.com example, your IP address is this is stored, not this, not this, not this, not this, because these are local private IPs, local. This is public outside. So Google server is there. Let's say the Google server will know that I have a request coming from this IP. Give the response. The response will go here, then will go here. In this way, you can manage all 4 billion IPs. It's like a scalable. Now it's scalable. So one IP is used by many devices in the network. So now you can use the problem. So that's why there is a concept of uh, public IP and private IP came. Yeah. So one thing you have to notice here is you cannot have two computers same IP here also. Now let's say another example. Let's say I have another network. I'll copy all. A second. Copy. Can I paste here? No, I can. Okay, I can paste. But I, okay, so let's say I have another network. Again, I'm taking switch, but I'm taking router, but that's not right. Let's have another network somewhere far. It is possible that I can also have same with these IP addresses. It is possible, right? Definitely. For example, this. See, so it's coming like that. Anyway, so it is possible that 192.168.1.1 191.168.1.2 92.168.1.3 something like that. So this is one network somewhere, let's say in Hyderabad. This is another network, let's say in Mumbai. You can have same private IPs here also, but the external IP is there, right? That external IP would be different. So that external IP cannot be same as this. It could be something different, but the private IPs could be same. It could be same because private IPs are never exposed on internet. They're only exposed within this network. So in a way, there is another area in Mumbai, let's say, three computers can have the same IP addresses, like private IP addresses as mine, but their public address might be different, cannot be same as mine. So that's why I say private IPs are local IPs. It's not exposed to the internet, while public IPs are exposed to the internet. In a way, this is my private IP, local IP. It's not exposed on internet. Like actually exposed on internet is this address, this one. So each website I visit, they will know this address. Each website I visit, they will know this address. They will be like, hey, this address wants to access Google page. This address wants to ask something. But I know internally that in this address has 5 devices. Each device has a different IP. So that is the difference between private and public. We use private IPs because we cannot assign each one a public IP. It would be very difficult because you only have 4 billion. So that's why the concept of private IPs came. You can use one public IP for the network, remaining all private. So that's how scalable of IPv4. So that's IPv4. This all. So there is also another variation we call IPv6. So IPv6 is 128-bit address. That's also IP address, but version 6. It's 128-bit address. In a way, you can think like 128 bits. The possibilities are very big. I can't tell you the exact number. It's a very infinite number. How many IPs? this is again coming, not everybody using it, but some companies use. See? So these many IP addresses are possible. Anyway, 340 undecillion like a big number. So IPv4 only 4.3 billion. Yeah, approximately 0.5 we already ran out. IPv6 new. Okay. They have many addresses. One person can use these many addresses. Again, not everybody uses IPv6 because new, of course, but people are adapting, so they might use IPv4. But idea is same, whether you use IPv6 or IPv4, the idea is same. You receive the data via IP address. Similarly, IPv6 also you can have both private and public. So you can have IPv4, V6 or V6 public plus IPv6 private. In a way, every computer has 4 IPs. One is that's IPv typically. I mean, you can turn it off, but you can turn it off settings. IPv4 private, or public, V6 private, and finally IPv6 public. So in a way, you can have 4 IPs typically. But you can always turn off IPv6, IPv4 by going to, I think, Windows, you have to go to settings, disable IPv6 on Windows. So you just have to go to settings somewhere. Yes, here. So just check box like you can disable, enable, depends on your, yeah, Windows key, control panel, network and internet, network sharing, change adapter settings, properties. Here if you check box, it's enabled. No checkbox, it will be disabled. So you can see IPv4 is there, IPv6. I think by default both are enabled. So you can unblock. You can see confirm. If you turn it off, you only can have IPv4 by these two. If you don't turn it off, you will have both. So in a way, you have 4 IP addresses. Technically, I'm speaking. Every computer usually have 4 IP addresses. I can also ask for my computer. Let me give me commands to show on map. Something like this. Yeah, something. Yeah, this is my local private IP. Now let's see. This is my local. This is my public IP. Both are same. Yeah, you can see this is my private IP. This is my public IP. So now I have 2 IPs, private, public, but these are IPv4. Now let's see IPv6. Yeah, so this is my IPv6 address. Public. Okay, so for me, public IPv6 is not given by internet provider. So I only have 3 IPs. One is private IP, public IP, IPv4, and the private IPv6 address. There is no public v6 for me. They did not give, I guess, ISPs. We never have three IPs. So this is not given. ISP, internet service provider, like the internet guys. But I do have all these three IPs. Yeah, so yeah, any questions, anything up to this point?